Hello, welcome to Leetcode Solver. Today we are going to solve 10th problem in May Leetcoding challenge and the problem name is find the town judge. Let's open the problem. In a town there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the town judge. Okay, if the town judge exists, if it exists, okay, then the town judge trusts nobody. Okay, everybody except the town judge trust the town judge. Okay, everyone trusts town judge, but town judge do not trust anyone. Sounds good. There is exactly one person that satisfies property 1 and 2. Okay, there is exactly one town judge. And you are given trust. An array of peers, trust I, A, B represents that person labeled A trust person labeled B. A will trust B. But if A is a town judge, then I mean if we have peer AB, then we are definitely sure that A is not a town judge because it doesn't trust anyone. So according to constant 1, if the town judge exists, okay, town judge may exist, may not exist and can be identified, return the label of the town judge, otherwise return -1. So which one is town judge we have to find out. Well, otherwise we have to return -1. So here if we see n is 2, we have a peer 1 2, 1 trust 2 and 2 trust no one. Sounds good. So 2 is a good candidate for town judge. Nice. If n is 3, then 1 trust 3. Okay. 2 also trust 3, but 3 trust no one. And both 1 and 2 trust 3. So 3 is a definite town judge. And here 1 trust 3, 2 trust 3, and 3 trust 1. So 3 also trust someone, and 1 trust someone, 2 trust someone. So the one who is in first side is not a candidate for the town judge because he trusts someone. So 1 is not a candidate, 2 is not a candidate, and 3 is not a candidate. So all of the members 1, 2, and 3 are not a candidate for town judge. So answer -1. And here we see 1 trust 2, 2 trust 3, but 3 do not trust anyone. That's fine. 3 is a good candidate. Seems like 1 is not a candidate, 2 is not a candidate, by the way. 3 seems to be good candidate, but 1 do not trust 3, so 3 is not a candidate. Well, so in this way you can find out like, so what I'm thinking is just if the we can just keep a track of the element which is first, like who is trusting someone, he is not a candidate for town judge, we'll keep that. And we also update the number of times somebody is being trusted, like we can say like trust score for that. Like for here we can see 2 has a trust score 1 because 1 trust 2, and 3 has a trust score 1 because 2 trust 3. So if we have somebody have trust score, like here we see 3 has trust score 1 here and 1 here. 3 has trust score 2, which is equal to n minus 1. So if someone has trust score equal to n minus 1 and that guy also not listed as a like it doesn't have any peer like A trust B, so this is not a first element in any trust peer. If that satisfies, then we are sure that that guy is a town judge. Well, so given a constant 1000 and 10,000 trust length, well, and there is no any like both candidate will not be same, and also all the values will exist 1 to n, and trust I are different. Okay, nice. Well, in that case, formulate, let's implement our solution. So as I explained earlier, solution, the complexity would be big of n, or n is given number of people in a town. Well, this is time complexity, time and space both complexity, because we need a space as well to maintain the trust score of everyone. Like let's define trust score as a vector of integer and say trust score of size. If we want to include 1 through n, then we need array of length n plus 1 because the zero index, array of size n plus 1 we need, and let's make everything 0 at first. This is for trust score. Now we need somehow we need to maintain the first element which is not a candidate for judge. We need to identify that. So we can also do it maintaining the vector as well. Also we can put it in a set and find out whether the candidate is judge or not. But we can also maintain set like not judge. Okay, is judge. Mm, but the town judge here. So let's say town judge. Town can be town judge, maybe can be town judge. Candidate, town judge candidate, maybe. Boolean vector, it's like Boolean is also sufficient. Bool. Uh, not not town judge. So let's initially not town judge. Somebody is not town judge. Or the variable naming seems quite what variable names may be suitable. Say can be town judge. Everyone can be town judge initially. So let's make everyone true. So anyone can be town judge. So can be town judge is true for everyone starting from 1 to n plus 1. So let's go through the trust vector. So trust peer and identified A and B as given in the statement AB. Well, so A will be trust peer. Trust peer is a vector, so trust pair 0 will be A and B will be trust pair 1, and if no any if condition, just make can be town judge to false for A. Now A can't be town judge, so can be town judge will be false for A. And another thing is trust score. Now trust score of B will be increased because somebody trusted B. Awesome. Now let's just go through element starting from 1 to n to all the people ID. If someone can be town judge is of somebody is true, and also trust score of that guy is equals n minus 1, then we are definitely sure that he is a town judge. And another there won't be multiple town judge because like the guy itself, the ith position, if he can be a town judge, that's why he do not have any link to other values, other any values. So that's why there is no any other values which can claim town judge, because there could be Kansas, but still trust score won't be n minus 1, because this guy itself reduced will reduce the score, because he is not giving score to that guy. So there won't be multiple town judge. So we can simply return whenever we find it. So let's return I. Otherwise, according to problem statement, we have to return minus 1. Okay, let's run the code. Awesome. Let's submit. Awesome. So this is accepted. Well, thank you so much for watching this video. Hope it helps you. And if you have any query or if any suggestion or any alternate solution, please feel free to comment. And yes, see you in the next video.